So far, we have looked at how one single numerical operation is carried inside a computer's CPU. Or in other words, we looked at how a simple addition of two binary numbers is done using the arithmetic and logic unit of the CPU. But in a typical CPU, addition is not the only operation it can do. A CPU can do many more operations. In fact, it can do much more complicated operations. These operations that a particular CPU can perform are called the instruction set of the CPU. The instruction set will depend on the CPU. It can change from one CPU to another. For example, the Z80 CPU manufactured by Zilog will have its own instruction set. Similarly, a Pentium CPU or a Core i7 CPU manufactured by Intel will have its own set of instructions. Embedded CPUs like the Atmel processor, which you commonly find in the Arduino board, or the ARM processor that you commonly find in your mobile phones and also in the Raspberry Pi computer board, will also have its own set of instructions designed to support the type of work that they are expected to do. Even though the instruction set itself is highly dependent on the type of the CPU, if you look at across different CPU manufacturers, we will see that there are common categories of instructions that are supported in almost every CPU. For example, there's a category of instructions or category of operations, what we call the data movement operations. These operations will help the CPU to move data from one place to another inside the computer. For example, moving data from input devices, reading them from input devices and then loading them into CPU registers, or reading something from the memory and loading them into a CPU register so that it can be used in a subsequent operation. For example, most CPUs will have an instruction called the load instruction. So the load instruction is used to, as the name implies, read a value from outside the CPU and bring it and store it in a register inside the CPU. So the outside the CPU place can be either memory or typically an input device, like for example the keyboard. Similarly, in the same category, there will be a instruction commonly referred to as the store instruction, which works in the opposite way of the load instruction. The store instruction will take a value from a CPU register and place it or send it to an external device. So you can use that type of instructions to save a value in the CPU register back in the memory, or send it value to an output device so that it can be sent to the external world. Another category of instruction would be mathematical operations, like the add operation that we discussed earlier. Similarly, CPUs may also support operations like subtraction. In some CPUs, you may not get a separate instruction called subtraction, but instead you get an instruction which can convert a number to a negative value. So with that, you can use the add operation itself to do the subtraction. You convert the number to a negative value and then add with the other value to get the subtraction effect. Similarly, some CPUs will have multiplication instructions, which allow two numbers to be multiplied. In some CPUs, the multiplication instruction will not be available. In those CPUs, you do multiplication by repeatedly adding again and again. In some CPUs, the mathematical operations will include even the floating point numbers, fractional numbers. But most CPUs will have only deal with integer numbers. A third category of instructions would be the logical operations, which compare two numbers or two values logically and give an output as the status of the comparison. Now these instructions are very special because they do not usually produce an output, but instead they produce as a status output which is sent through the F register in our ALU, which we discussed earlier. So they, like the add instruction, they do not produce something like the sum output, but only produce the status value which can be used by some of the subsequent instructions to take decisions, for example. So example for a logical instruction would be the compare instruction, which compares two numbers and set the status depending on whether one number is equal, greater than the other, equal to the other, or less than the other. Then there will be other operations which are called the CPU control instructions, which changes the way the CPU would normally operate. For example, a CPU would normally execute instructions in the sequential order as they appear in the program. It will take the first instruction, once it is completed, it will go to the next one. So it will go through the sequential order. But there are instructions like the jump instruction, which will ask the CPU to move to a different place in the program rather than the next instruction immediately available. So the jump instruction, when provided with the address of a memory location, will straight away jump to the new location depending on the logic that is used in the program. For example, if you are in a loop, so the loop, when you reach the end of the loop, you will jump back to the beginning of the loop to continue that. So that jump is an unconditional jump. There can be another jump instruction, another type of jump instruction, which says jump only if 0, which means that the jump will occur only if the last logical operation that you carried in the ALU has resulted a 0 value. For example, when you are in a loop, there should be a jump instruction where to check whether you have completed the number of iterations in the loop, and if so, jump out to a location outside the loop. So in that context, the first instruction will compare two values, maybe your loop counter with the end of the loop, the size of the loop, number of iterations, and if it is equal, the comparison will be 0 because two numbers are equal, will result a 0 result as the status, and then you execute the jump z instructions or jump if 0 instructions to move out of the loop. Similarly, there can be another instruction which is jump if not 0, which will execute the jump if the last operation has resulted a non-zero value. There is also another very special instruction which is found in almost every CPU, that is called NOP instructions or no operation instructions. Why you need an instruction which will do no operation? This particular instruction will not carry out any task. It will simply get loaded and that's all. So why you need this? Because we will need it. Sometimes we want the CPU to wait without doing anything. For example, it might wait until a user presses a key in the keyboard. Until you find a value in the input device, it has to keep on waiting. So a CPU can't wait without doing something, so it has to do something which is doing nothing. So it will keep on repeatedly executing these NOP instructions or no operation instructions until some condition is set so that it can move out of that loop and do some other work. So that's also a very important instruction in the CPU design.